Lesson 5.5, Performing Function Operations. Sometimes, for your problems, you need to repeat several calculations over and over again, like in science class. It might be easier to combine all the equations into one big equation first. Then you'll only have one equation each time instead of many. So like I had a class of physics lab that I had to do in college, where I had to take the same measurement like 200 times. And then it had to run through 3 different formulas before I got my final answer. So it's far easier to combine all 3 formulas first, and then I could make a simple plug it in and get my results. There are 5 ways to combine functions. The first 4 are pretty straightforward. Addition, we just add the functions. We can write it either as f plus g of x or f of x plus g of x. We could subtract. We could multiply. Or we could divide. It's multiply. It's not a question mark. It's multiply. All right, given f of x is 5 times the square root of x, and g of x is negative 8 times the square root of x, find f plus g. Well, hey, we'll have 5 times the square root of x, that's our f, plus the g. So 5 plus a negative 8 is negative 3 square roots of x. So this was the like terms. 5 of them plus negative 8 of them is negative 3 of them. Well, let's try subtracting. So it's f minus g. Minus a minus makes a plus. And again, the square root of x is our like term, so 5 plus 18, or plus 8, makes 13 of the square roots of x. Let's try multiplying. I don't know why it doesn't like the multiply symbol. Let's multiply them. 5 square root of x times negative 8 square root of x. It's f times g. You can multiply the numbers. And then square root of x times square root of x would be square root of x squared. Or just x. And we could divide them. So it's f divided by g. Square roots of x cancel out, and we're left with negative 5 over 8. Let f of x be that and g of x be the other thing. Find f minus g of x, state of the domain, and then evaluate when it's negative 1. All right, so we're subtracting, so it'll be f minus g All right, so combine like terms. I have 2x cubed minus 3x cubed, so it'd be negative 1x cubed. I have 4x squared minus a negative, so that's plus 5x squared, would be 9x squared. Negative 8x minus 6x would be negative 14x. And 4 minus a negative, so plus 9. 4 plus 9 is 13. And there we go. That's what it is. The domain is all real numbers because it's polynomial. Polynomial functions, domain is all real numbers. And then if we plug in a negative 1, so negative 1 cubed is negative 1 times a negative makes positive 1. Negative 1 squared is positive 1 times 9. Negative 1 times negative 14 is positive 14. 1 plus 9 is 10, plus 14 is 24, plus 13 is 37. So f minus g of negative 1 is 37. Let's try another one. We have f and g again, and this time we want to multiply them. So we're going to multiply them. So f of g, or f times g of x, start with the x first, would be f times g. Well, how could we combine this? Well, remember the square root of x is exponent of a half. And then we could add these, but we need a common denominator, which would be 2. So this would be 6 over half. And we're adding the exponents. When you multiply at the same base, you add the exponents, it'll be x to the 7 halves. And then we want to plug in a 4. So f times g of 4 will be 4 to the 7 halves. Let's see if we can do this on our own. Well, you can put it in the calculator. But remember, that's the index, so it could be the square root of 4 to the 7th power. Square root of 4 is 2. 2 to the 7th is 128. From 2010 to 2020, the population of thousands of city M and N can be modeled by these, where T is the number of years. Find N minus, okay, M, so we'll do M minus N okay, combine like terms. So the 3.3 t cubed minus 2.5 t cubed would be 0.8 t cubed. The squared's 12.1 minus 7.8 is 4.3 t squared. Just the t's, I have negative 6.5 minus 0.41, which would be negative 1.06. And then the numbers, 15.8 minus 11.9 is 3.9. And what does it represent? Well, subtracting the populations gives how much greater the population M is than N. So it is the difference in population since 2010.